So I'm gonna ask you guys about surface tension. Have you heard of it before? Hi, my name is Amber. Hi, I'm Michelle, and we are currently in honors chemistry. Period 2. Chase. And today we're gonna be talking a little chemistry. Chemistry is not only slightly difficult, but it's also one of the most interesting courses that they offer in high schools. So we decided that we might go out and test some people on some facts on chemistry on the spot, particularly the concepts of properties of water, so surface tension, and acids and bases. So let's talk about surface tension. Have you heard of it?
It sounds familiar.
I have. What do you think surface tension is?
Hydrogen bonds, I believe, and
because hydrogen is
those little
so
walk
strong,
bugs, they're able to walk on it.
they bond into each other and then they create this
We did a
permeating layer
paperclip
on
lab.
the top
We
of
did
the
a
water.
paperclip lab this year.
I think it's like
surface tension,
like this, like
the surface, and then there's
like the tension of like the surf, like
I know.
But I think it was on.
Like how hard the surface is and how much like force is placed on it.
Tension, I remember a good example was like we used to drop water and it'd be like you could see like little bubbles. So it was just like the surface tension was how well it like held itself together before breaking apart. I remember doing a lot like that. We just kept adding drops on top of a nickel or a penny. I thought it was a penny.
So, water bonds together using hydrogen bonds. And so as it bonds together, it creates a layer where the water is very hard on top. And it's very hard to break this layer. And so when you break the layer, like for instance when you have a bunch of water drops on a penny and it stays together, even though it looks like it should fall off, if you break it, it splits apart because you broke the bonds in the water. But the hydrogen bonds keep surface tension together, which keeps all the water together.
So we're going to move on to acids and bases. What do you consider your definition of an acid or base?
Acid?
Something that burns.
Something sour.
Orange juice, lemonade, like lemon juice, stuff that burns your cut. Like
It's like on a pH scale, and if it's below 7, then it's acid, and if it's above 7, it's basic.
I know this one. An acid is if it has a pH lower than 7, and a base is at a pH higher than 7.
Acids are substances that have a high amount of hydrogen molecules, while bases have OH or hydroxide molecules.
So we're going to play a little game right here. These are going to be some utilities that you're going to use right now. You got a pink highlighter and a blue highlighter. The blue means base, the pink means acid. I'm going to give you examples of everyday items that you have in your household or that you're surrounded by, and you're going to guess, is this example acidic or is this example basic? So what about the battery juice you put in a car? Acid or base?
Acidic.
What about the stomach juice in your stomach?
Acid.
Coffee. It's actually acidic. Baking soda. Toothpaste.
no, there's no way because you put it on your teeth. You don't put acid on your teeth, do you?
That has fluoride.
Liquid drain cleaner.
Basic.
Cleaner.
Basic.
And last but not least, water.
Neutral.
No, none of us, both of us. Get it out. Put it up.
Neutral.
Perfect.
So first we went around the campus at lunch and we randomly selected some students to talk about properties of water, specifically surface tension. And Well, first of all, surface tension is the measurement of the inward pull by the particles from the interior of the liquid. And one really common example of this would be little bugs or a spider gliding across the surface of a body of water without sinking and drowning. So water has a really high surface tension because the molecules can form multiple hydrogen bonds, and things such as soap or detergent can break those bonds or disturb those bonds, and those are called surfactants. And when water tension is broken, the water molecules spread out and anything that's on top of it falls in. So if you were to take a cup of water, place a paper clip on top, and then add some soap, which is also called a surfactant, it will break the surface tension and the water will spread out and the paper clip will fall to the bottom of the cup.
So the next thing that we actually talked about were acids and bases. Acids and bases are normally determined by their pH or pH scale. This pH scale is numbered up to 14. I just saw an owl. So this pH scale is actually numbered up to 14. Anything of lower than a pH of 7 is considered acidic, and anything higher than a pH of 7 is considered basic. pH of 7 is simply neutral. Acids are normally sour tasting, and they're normally found in like citrus fruits and juices like, you know, orange juice, lemon juice, lemons, oranges, apples. And bases are actually the complete opposite. Bases taste bitter, and they are generally found in cleaning products that you find around the house, like Windex or bleach or drain cleaner. At the end of it all, everyone actually seemed to prove themselves really well. Not that many knew about, much about surface tension, the properties of water. I mean, that's understandable. Not everyone's going to be like, oh yeah, hydrogen bonds, and if you add a surfactant, it's going to break the surface tension. It won't be able to hold much anymore. So, in a way, yeah, I understand why not many people knew much about surface tension.
But a lot of people were able to guess whether something was an acid or a base, just knowing that, like, the certain aspects of an acid, and if it didn't seem acidic, it was a base. So a lot of people were good at that.
So it just goes to show that even if some people didn't take a chemistry course, they're still surrounded by chemistry every day, and pieces of chemistry are embedded in all of our science, and it's a very important part of education in general.
And life.
And life.